Hi, y'all. Welcome back. Topic 3, day 3. Today we are going to discuss solving equations with one variable as well as solving rational equations, basically fractional equations, which I know is all of your favorites. Hold your applause until the end. So first we are going to start with linear equations. These should be very, very easy. You guys have been doing these since you were in middle school. So this is not going to be anything new. Okay, we solve them using opposite operations. All right, so again, opposite of add is subtract, opposite of multiply is divide, divide is multiply, so forth and so on. So if we wanted to solve this very first problem, 7x plus 2 equal 23, right? I think we all know how to solve this. We would subtract 2, so 7x equals 21. And then the opposite of multiply is divide. We would divide by 7. 21 divided by 7 is 3. All right, hopefully that's relatively easy. If you forgot how to do it, you want some more examples, by all means ask and we can do that, okay? The second question, a little bit harder. Now there's x's on both sides. So our goal is to get all the x's to one side and all the numbers to one side. So there's a million ways, I shouldn't say a million, there's a few ways you could start this problem. I am going to start by subtracting 3. Okay, you didn't have to do that first. That's just what I chose to do. So the 3's will cancel. 7x equals 3x. Negative 17 minus 3 is negative 20. So I've got all the numbers on one side. Now I need to get this 3x out of there. So subtract 3x because it's positive. So those cancel. 7 minus 3 is 4x equals negative 20. And then it's just like before. This is 4 times x, so we divide by 4. So x equals negative 5. And we're done. Okay? So again, the same thing you all have been doing, just memory refresher. Okay? The third example right here. There's only 5 examples today, so we're almost done. The third one. So first what we need to do, remember, whenever there's a number in front of parentheses, okay, we always distribute it. So we're going to distribute the 3, and we're going to distribute the 5. So 3 times x is 3x. 3 times 3 is 9. Do the exact same thing on the other side. 5 times 1 is 5. 5 times x minus 5x, and I still have that minus 1 on the end. All right, so this one just adds a little extra step in there. If you notice on the right-hand side, I have some like terms, right? I have the 5 and the minus 1. Okay, so I have the 5 and the minus 1, and I can put those together. So the left side is not going to change yet. So it's going to stay 3x plus 9. But the right side, 5 minus 1 is 4, so it's going to turn into 4 minus 5x. And then it's exactly like the problem we just did. Get all the x's together, get all the numbers together. So this one, I'm going to start by adding 5x to both sides. Again, I didn't have to do that. Just looked good to me at the time. So 3x plus 5x is 8x plus 9 equals 4. Then we would subtract the 9. 8x equals negative 5. And we divide by 8. So x equals negative 5. And we're done. Okay, so distribute first, combine like terms, and then get all the variables to one side, all the numbers to one side. All right, so hopefully that's relatively easy and refreshed your memory. The next question, the back of this is going to be a little bit harder. So now what we're going to talk about is we're going to talk about rational equations, okay, fractions basically. All right, so what we need to do on all of these is we need to go through these 4 steps. All right, so we need to find the least common denominator, then we're going to multiply all of the terms, however many there are, by that least common denominator. Okay, when we do that, it should clear all of the denominators. Basically, the denominators should all go away. They should all turn into 1. Okay, we should be able to cancel things out so that it becomes a 1 and there's no more fraction. That's why we're doing this. So multiplying by the least common denominator will eliminate the fraction aspect of it. Okay, then we're going to solve it just like we did on the front. And then we have to check for what we call extraneous solutions. All right, that's basically an answer that we got that doesn't actually solve the problem. And you'll see what I'm talking about in just a minute. Okay, so let's do this first problem. 1/4 minus x equals 1/8 x. So what we need to do first is figure out what is the least common denominator. So we need to figure out what's the LCD of this thing. All right, so I have a 4. this is like a 1 over 1, basically. Right in front of the x is a 1, so that's 1 over 1 in an 8. So the least common denominator between about 1 and 8 would be 8. That is the smallest number that they all will go into. Okay? So then the second step was to multiply every term by that. So what I'm going to do is I'm going to take this 8 and I am going to multiply it times every single term. So 8 times the 1/4 minus 8 times that x equals 8 times the 1/8 x. So I multiplied that least common denominator by all 3 of these. If there would have been 5 of them, I would have done it times all 5 of them. Okay? Doesn't matter how many there are, just multiply them all. So then if you're not good with fractions, this is where your calculator will come in handy. 8 times 1/4 is 2. 8 times x is 8x. And 8 times 1/8, 1/8 of 8 is just 1. So I've gotten rid of all of the fractions, right? I eliminated all of the denominators, which is exactly what we wanted to do. Okay, I was able to eliminate them by multiplying by the LCD. So now we just solved this, like we did on the other side of this paper. Add 8x, I apologize, to both sides. That would give us 2 equals 9x, then divide by 9. 2/9 equals x. 2/9 equals x. So that's our answer. But the problem with this is just because that's our answer doesn't mean that it actually works in the problem. So my last step, I'm going to write it up here, is to take that answer and put it back into this problem and see if it works. Okay, so 1/4 minus x was 2/9 equals 1/8 times 2/9. So everywhere there was an x, I plugged this 2/9 in. Capiche? This is where your calculator will really come in handy, okay, if you don't like fractions. In order to subtract fractions, we have to get a common denominator, right? So I would multiply this first one by 9 and the second one by 4 to get a common denominator. So that would be 9 over 36 minus 8 over 36. Then over here, to multiply fractions, multiply top times top, bottom times bottom. So that's 2 over 72. And now we can simplify. 9/36 minus 8/36 is 1 over 36. 2 over 72, I could reduce that to also 1 over 36. So we know that that answer actually works. Okay, that answer makes sense for our problem. So it is an answer. If we would have done all this work and this wouldn't have matched at the end, we would say that this answer is extraneous. Okay, meaning it worked when we solved it, but it doesn't actually work if we plug it back in. Okay, so remember, extraneous after you check it is when it doesn't actually work. All right? Okay, the last one. Now it's going to get a little bit harder. So now I have a binomial on the denominator. Right before I didn't have a binomial. So again, we still need to find the least common denominator. All right, so basically everything that's in the denominator needs to be a part of the least common denominator. So in this case, my least common denominator would be 2, and there's a 5x plus 6. That is my least common denominator. Okay, 2 times 5x plus 6. So just like the example above it, I'm going to multiply both of these by that. Okay, so it's going to look a little sloppy here for a second. So 2 times 5x plus 6, that's the least common denominator, times this. So times 10x plus 3 over 5x plus 6 equals this again, the least common denominator, 2 times 5x plus 6 times 1/2. All right, now remember I told you at the beginning, the whole point of this is so that we can get rid of the fractions. So if I was multiplying these two together, Okay, this 5x plus 6 on bottom is going to cancel that 5x plus 6 on top of that one. So we got rid of the denominator, but I'm still left with this 2 times the 10x plus 3. On this side, on the right side, the 2's are going to cancel. And I'm just left with 5x plus 6 times 1, which is just 5x plus 6. And now this is exactly what we did on the earlier examples. Distribute the 2. 20x plus 6 equals 5x plus 6. And then simplify however you want. I'm going to subtract 5x. So this would be, I'm going to write it over here. That would be 15x plus 6 equals 6. Then subtract 6. 15x equals 0. Divide by 15. X equals 0. So I got an answer of x equals 0. Just because I got an answer doesn't mean that answer is right. Okay? So now I have to check it. I have to take this 0 and I'm going to plug it back into my original problem, the one we started with, to see if it works. So 10 times 0 plus 3 over 5 times 0 plus 6 equals 1/2. 10 times 0 is 0. 0 plus 3 is 3. 5 times 0 is 0. 0 plus 6 is 6. 3, 6 reduces to 1/2. Ding, 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 ding. It worked, right? So that means 0 is the answer to this problem. It is not extraneous because we checked it and it worked. Okay? So that's topic 3, day 3. Solving rational equations and solving equations with one variable. Deuces.